The first lesson in Chapter 7 is ratios and proportions. A ratio is a comparison of two quantities. It can be written as a fraction, a over b, or written with a colon, a to b. Let's look at some examples, and we're going to refer to the squares on the right. So we want to write the ratio for each of these. Number 1 is gray to white. So there are 3 gray and 2 white. So we can write that as a fraction, or we can write it with a colon, 3 to 2. Number 2, white to gray. So we can write that there's 2 white to 3 gray, or we can write it as a colon, 2 to 3. Number 3, gray to all. So there are 3 gray, and there are 8 squares in all. And number 4, all to black. There are 8 squares in all. There are 3 that are black. In the next two examples, we are going to write the ratio of height to base for each triangle. So in number 5, our height is 4 and our base is 6. And then we want to reduce our ratio. So this has a ratio of 2 to 3. In number 6, our height is 13 feet and our base is 9 yards. So I'm going to make our base 9 yards is the same as 27 feet. You want to make sure you have the same units before you write your ratio. So my ratio, height to base, would be 13 to 27. A proportion is a statement that two ratios are equal. So we have two examples of proportions. The first one written with fractions. We can say A is to B as C is to D. And then the second one written with colons, we would read it the same way. A is to B as C is to D. An extended proportion is when you have 3 or more ratios that are equal. Some properties of proportions. So if A is to B as C is to D, then the 4 following properties are true. Number 1, that A times D is equal to B times C. Number 2, A is to C as B is to D. So notice B and C just flip-flopped. Number 3, B is to A as D is to C. So each of the ratios flipped. And number 4, A plus B is to B as C plus D is to D. So we added our denominator to our numerator and kept our denominator the same. And notice that the same thing occurred in both ratios, so then our proportion still holds true. So make sure you get these 4 properties down on the bottom of your notes. In the next examples, we're going to complete each statement. So it says A is to 6 as 18 is to B. So in number 7, we have B is to 18. So notice we took our second ratio first and we flipped it. So then that means I need to flip my first ratio. So this would be as 6 is to A. In number 8, A times B, so there's the cross product. So take 6 times 18, or A times B is equal to 108. In number 9, A plus 6 is to 6, so we added our denominator to our numerator and kept the denominator the same. So we'll do that in our ratio on the right. We'll have 18 plus B is to B. And in 10, A is to 18, so notice the 18 has to switch with the 6, so we'll have as 6 is to B. Okay, next examples, we're going to solve each proportion. So remember, to solve a proportion, you are going to take the cross product. So we will take 2 times x is equal to 3 times 18, or 54, and then divide both sides by 2 we get x equals 27. In number 12, again, taking the cross product, so 2 times 35 is 7, and then 5 times n is 5n. Divide both sides by 5, and 14 equals n. In 13, 16 times 9 is 144. X times x is x squared. Now, to solve for x, we will take the square root. Square root of 144 is positive or negative, 12. So that equals x. In 14, x times x is x squared. 32 times 2 is 64. We'll take the square root of both sides. So x is equal to positive or negative 8. Now in 15 and 16, our proportions get a little more complex where we have an expression in one of our ratios. So in 15, I'm still taking the cross product, but this time we're taking 2 times x plus 1 equal to 3 times x. And make sure you write with parentheses because we have to distribute to both terms. Subtracting 2x from both sides, we get that x equals 2. In number 16, same idea. Take 18 times n, 18n, and then 6 times n plus 6. So 18n equals 6n plus 36. Subtract 6n from both sides. So 12n equals 36, and divide by 12, n equals 3. Our last examples, we're going to refer to the scale drawing to solve each problem. So here we have the layout of a house. And a key thing to note here is our scale, which says that 0.25 inches is equal to 1 foot. So we are going to want to figure out the dimensions of our rooms in feet. So 17 says, what is the length of the kitchen? Well, first we're going to write our ratio of our scale. So 0.25 inches is to 1 foot, as 3.75 inches is to how many feet for our length of our kitchen. So we're going to be writing proportions to find what our lengths and widths are in terms of feet. So we can take the cross product and divide to find x. So the length of our kitchen is 15 feet. 18, what is the width of the living room? So again, our first ratio will be our scale, so 0.25 inches to 1 foot, as 2.5 inches is to how many feet? Take the cross product and divide. We get that the width of our living room is 10 feet. So it does not matter the order you set your ratios up as long as they go in the same order. So how I'm writing my scale as inches over feet, then my ratio on the right must be inches over feet. So in 19, we're looking for the length of the dining room, which is 2.5 inches on our scale. We want to figure out how many feet that is. So take the cross product and divide to get the length is 10 feet. Okay, and finally number 20, what is the length of the hall? So our first ratio is our scale. The length of the hall is 1.75 inches. And how many feet is that? So take the cross product. And we get that the length of our hall is 7 feet. Okay, And that's the end of our first lesson in Chapter 7 on ratios and proportions.